Yeah, good afternoon. My name is Mr. Amusa Wasiu, and this afternoon I'll be taking you through the topic electrolysis. Now, what is electrolysis? Electrolysis is defined as the chemical decomposition of a compound which takes place when an electric current is passed through either a solution or the molten form of the compound. Now, not all compounds can allow electricity to pass through them. Now, those few compounds that allow the passage of electricity to pass through them, they are called electrolytes. Now, what is an electrolyte? We say electrolyte can be defined as a compound either in solution or molten form that allow electricity to pass through it, and at the same time is decomposed at the electrodes in the process. Examples include acids, alkalis, and some soluble salts like sodium chloride, calcium chloride, and others. So we have, on the other hand, a non-electrolyte, and a non-electrolyte does not conduct electricity at all. It doesn't allow electricity to pass through it. So examples include non-distilled water, sugar, urea, ether, and benzene. Now, by the time we look at the electrolytes can be grouped into strong electrolytes as well as weak electrolytes. Now, the strong electrolytes are those electrolytes that ionize completely in solution, and so they are composed of moving ions. Now, when we talk about ionization, we're talking about the separation of the ions. So, for instance, now when I put sodium chloride inside water, the ions present separate into the different sodium ion and the chloride ions. So, what we're saying is that for strong electrolytes, there is complete ionization. So, and they are not composed of moving ions. They conduct electricity readily, while weak electrolytes, on the other hand, ionize partially or slightly in water, and so they do not conduct electricity readily. A good example is the ethanoic acid. Now, moving on, we also have another thing to talk about, that is the electrodes. Now, what do we mean by the electrodes? The electrodes are conductors through which electric current enters or leaves the electrolyte. And our electrodes are of two types. We have the anode, which is the positive electrode, and it is the electrode through which electricity leaves the electrolyte. Then we have another one which is called the cathode, and the cathode is called the negative electrode. It is joined to the negative terminal of the cell or electric supply, and it is a point through which electrons enter into the electrolyte. Now, by the time we look at the electrolytic cell, the electrolytic cell is just the assembly of two electrodes in an electrolyte that is connected to a source of current for the electrolysis of the substance. Now, if we take a look, this is a diagram of the electrolytic cell. Inside this beaker, I have my solution. Now, the solution I'm talking about now is the electrolyte. Now, we can see that we have placed the electrodes inside. Now, here we have the cathode, and like we said the cathode is the negative electrode through which electrons enter into the electrolyte. Now, we can see that the flow of electricity will be from the negative terminal of the cell of the battery or the source of electricity through the electrode into the electrolyte, while on the other hand, electrons leave the anode, and from the anode goes into the source of electric supply. Now, we're going to look at the mechanism of electrolysis. Now, this is where we need to pay much attention. Now, before the passage of electric current, it is said that the ions in the electrolyte move about randomly. And now, when I say they move randomly, what I mean is that they have no direction. So, when electrolysis begins, electrons are pumped into the cathode from the negative terminal of the cell. So we're going to see this. Let us look at this video. Now we can see this is the electrolyte and these are the electrodes. Now from what we said the other time, we said that the electrode that is connected to the negative terminal of the cell is what we call the cathode, while the one that is connected to the positive terminal of the cell is what we call the anode. And like we said the other time, we said that electrons are pumped into the electrolyte through the cathode, while electrons leave the electrolyte through the anode. And by so doing, we see that the charge of the cathode will be negative, while the charge of the anode will be positive. Now, if we should look at what happens. Now, immediately this is going on. This is electrolysis. Now, this is the state of the electrolyte. This state of the, and we can see the random movement of the ions. Now, immediately electrolysis starts, the cathode becomes negatively charged and the anode becomes positively charged. Now, when this happens, something happens to the random nature of the electrolyte, of the ions in the electrolyte. Since the cathode is now negatively charged, all the cations, and what I mean by cations, I mean the positively charged ions in the electrolyte are drawn towards the cathode. Now, on the other hand, all the negatively charged anions are drawn towards the anode. Now, we can see as we have it there. So the anions are drawn towards the anode. So this is what happens during electrolysis. Here we have the cathode, here we have the anode. So now, like we said, electrons are pumped into the cathode from the negative terminal of the cell. Now the cathode becomes negatively charged and attracts the positive cations in the electrolyte. The cations, on getting to the cathode, accept electrons and they become discharged as neutral atoms. Now, on the other hand, the anode on the other hand loses electrons to become positively charged and attracts the negatively charged anions in the electrolyte. These anions then lose electrons to become discharged as neutral atoms. Okay, now, if we are to consider this example, one look at the example, the electrolysis of molten sodium chloride using inert electrodes. Now, I want us to take note of the word molten. Now, when I say molten, I'm talking about the melted form of sodium chloride. And when I using the melted form of sodium chloride, the only ions that are present are the sodium ion and the chloride ion. And like we said the other time, we said when electrolysis starts, here we have the source of electricity. This is the negative terminal and this is the positive terminal. And we have said that the negative terminal is connected to the cathode, while the positive terminal is connected to the anode. Here we have the anode. Now, we said the cathode becomes negatively charged while the anode becomes positively charged. Now, immediately the cathode becomes negatively charged, it attracts all the positively charged ions present in the electrolyte, which are sodium ions. Now, all the sodium ions are attracted towards the negatively charged cathode, while all the anions, talking about the chloride ions, are attracted towards the positively charged anode. Now, what happens at the cathode? The type of reaction that occurs at the cathode is reduction. And we call it reduction in the sense that there is a gain of electron. Now, the sodium ion migrates to the cathode where it gains an electron, to become discharged as sodium solid to become the well, like I said, the sodium ion picks up an electron to become discharged as sodium solid. Now, the taking in of electron is what we refer to as reduction. Now, at the anode, the opposite happens, which is the process of oxidation. Now, for this, there is a loss of electron. Now, what happens is that each chloride ion gets to the anode and loses one electron each to be discharged as chlorine atom. Now, this is written as this. But we all know that chlorine cannot stand on its own. Chlorine atom cannot stand on its own, being a diatomic element. So to balance this, I'll put 2 air, then it will be, put 2 air, then I have 2 air as well. Now, we need to write the overall reaction equation. And to write the overall reaction equation, we're going to have 2 Na plus 2Cl minus to give 2 Na solid plus Cl2 gas. Now, this is the overall reaction. We are going to stop here, and in our subsequent videos, we're going to look at the factors that affect the discharge of ions at the electrode. That's talking about preferential discharge of ions at the electrodes. We're also going to look at the electrolysis of some other compounds. We're going to look at them of copper sulfate, as well as go into the calculation. But for now, we want to thank you for viewing, and we'd like to see you next time. I remain Mr. Amusa Wasiu. Thank you.